Good morning, everyone. Welcome to this session number 8 on applications of Google Earth Engine. Today, we will see basic applications of Google Earth Engine for regarding flood monitoring and flood mapping, and some we will also see some scripts regarding agricultural water management and drought monitoring. So the faculty for today's sessions are Ms. Pragati Singh and Mr. Ashutosh Singh. Ms. Pragati Singh did her MTech in remote sensing. He worked in Remote Sensing Application Center, Uttar Pradesh, as a project scientist on World Bank funded project UPWSRP Phase 2. Mr. Ashutosh Singh, he did his MTech in remote sensing and GIS from IIRS Dehradun. He also worked as a project scientist in Remote Sensing Application Center, Uttar Pradesh. Currently, he is working as a junior remote sensing and GIS expert in National Water Informatics Center, New Delhi, Ministry of Jal Shakti. So I would invite Ms. Pragati Singh and Mr. Ashutosh Singh to take over and please deliver today's session. Thank you.
Good morning, everyone. I am Pragati Singh. So today I am going to discuss about flood monitoring and drought monitoring in Google Earth Engine. So let's start. My screen is visible?
Yes, it is visible. Okay. Pragati, you have, I think, some presentation also to show?
Yes, sir. So today's session is flood monitoring using microwave data in Google Earth Engine. It will be presented by me and Ashutosh Singh. So why we use remote sensing for flood monitoring? Because during the flood, it is not possible to go to the flooded area. So we are using the satellite data. But in the satellite data...
Full screen kar lo. Full screen.
Okay, sir. In the satellite data, there are different type of satellite data. So in visible range, we are using the red, blue, and green band. So this band cannot penetrate through the cloud. So that's why we are using the microwave channel, because it has the longer wavelength, and longer wavelength can penetrate through the cloud. So we are using the microwave data for monitoring the flood. So the portion of spectrum of more recent interest to remote sensing is the microwave region, from about 1 mm to 1 meter. This covers the longest wavelength used for remote sensing. The shorter wavelength have properties similar to the thermal infrared region, while the longer wavelength approaches the wavelength used for radio broadcast. So when the wavelength will be higher, then it can more penetrate through the objects. So the remote sensing using microwave spectrum is termed as microwave remote sensing. So in this picture, you can easily see that microwave region can easily penetrate through the cloud, but in optical region, it cannot penetrate through the cloud. So microwave remote sensing covers electromagnetic spectrum, as I said, 1 mm to 1 meter. Because of their longer wavelength compared to the visible and infrared, microwave have a special property that are important for remote sensing. Longer wavelength microwave radiation can penetrate through the cloud cover, haze, dust, and all but the heaviest rainfall, as the longer wavelengths are not susceptible to atmospheric scattering, which affects shorter optical wavelength. This property allows detection of microwave energy under almost all weather and environmental conditions, so that data can be collected at any time. So we can collect the data at any time during the day or during the night. In optical region, we cannot collect the data during the night period. So in microwave region, we can also collect the data during the day, night, or in any weather condition. That's why we are using the microwave data for flood monitoring. So there are two types of microwave remote sensing. One is active and another is passive. Passive is as similar to the optical region. The sun is the source of energy, and it's in the electromagnetic spectrum, the light of sun interacts with the object and it reflects back to the sensor. Then it will record it. And another is the energy of the sun that is absorbed by the object and it emitted and recorded by the sensor. In the active remote sensing, the sensor sends its own energy to the object, and that is collected by the sensor again. So that is the active remote sensing. So the basic of passive and active remote sensing is passive uses the natural energy, either reflected sunlight, solar energy, or emitted thermal or microwave radiation. In active sensor, it creates its own energy that is transmitted toward Earth or target, interacts with the atmosphere or surface, reflect back towards the sensor as a backscattering energy. So there are type of polarization when the energy sent to the object that is polarized, because unpolarized energy vibrates in all the possible direction perpendicular to the direction of travel. So we have to send the energy that is in polarized manner, either in vertical format or in horizontal format. So the pulses of electromagnetic energy is filtered and sent out by the antenna, may be vertically or horizontally polarized. The pulse of energy received by the antenna may be vertically or horizontally. So there are two types of energy that is sent by our sensor to the object, that is vertical or horizontal. When we send vertical energy through the sensor to the object and received it vertically, that is VV type of polarization, vertical. And when the sensor sends the energy in horizontal format and receive it horizontally, then it is HH polarization, as horizontally sent and horizontally received. But there is cross polarization also. When the sensor sent energy vertically but received horizontally, then it is VH polarization, vertical sent and horizontal received. And in HH polarization, HV polarization, the horizontal energy sends and vertical received. Why we are using polarization? That is depending upon the what object of the Earth's surface we are trying to monitor. It is depending upon the monitoring of the target, because in microwave region we are collecting the information that is backscattered energy. So when vertical energy sent and vertical received, then it is good for the water body or any other phenomena that is not rough on the Earth surface. In horizontal, that is for volumetric information, and for cross polarization is also used for the biomass estimation or other applications. So this is the polarization, why we are using it. So that's is it clear? So in the microwave region, there are different types of band. As in optical region, we are using NIR. In multispectral, there is NIR band, but in optical, red, green, and blue. When we are using the multispectral region, then NIR, SWIR, shortwave infrared, middle wave infrared, that's these bands are used. But in microwave region, the band denotes as a Ka band, K band, Q band, X band, C band, S band, L band, and P band. As the wavelength increases, the properties of these bands are changing. Like C band is, we are going to use the C band for flood monitoring. It is available in Sentinel-1 imagery. So why we are using microwave data? So you can easily see this is the optical image of Bihar recent period. there is too much cloud. So we are not able to identify where the flooded area. But this is the microwave data of Bihar. So we can easily find out that these black patches, which is shown in black, that is the flood affected region. So we are using the microwave data for monitoring the flood. My voice is okay or I'm going fast? Hello? Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Is it okay or I'm going little bit fast?
It's okay.
It's okay,
Please
ma'am.
continue.
Okay. So here, variable images. So here, what we are going to do, we are just going to season-wise composite image. So we
Please,
are just
Pragati,
filtering the data. Yes, sir.
Pragati, please explain the purpose of any script in the beginning and the data set which you are using, and then you can
Yes, sir.
explain line by line. Yeah.
Yes, sir. This script is related to the flood monitoring, and here you can see before flood, after flood, or any time period of flood imagery. You can easily visualize using this swapping tool. So for that, this script is built for monitoring the flood affected area to visualize which area is affected with the flood. So in this script, we are going to use the Sentinel-1 data, because it is the microwave data. Earlier you have used the Sentinel-2. This is Sentinel-2, that is multispectral data. But we are going to use the Sentinel-1 data, that is microwave data. So when we click here, this is the description. So this data is 10 meter with a spatial resolution of 10 meter, 25 meter and 40 meter. And the bands, that is HH band, as I said, this is the polarization. That polarization energy which is recorded, that is considered as a band. In this microwave data, the band name is HH, HV, VV, but we are using the C band. So don't confuse with that. The name that polarization give as a band name in this Sentinel-1 data. But the band which is used in the Sentinel-1, that is C band. But they name the energy which is recorded, the polarized energy, they named this as a band. So band name is HH, HV, VV and VH. And the value of these bands are from -50 to 1 for all the band, and spatial resolution is 10 meter. So when we import it, we can directly use it. We have imported it, the image collection. Another format to importing the data is just go here and copy this line directly, or you can copy it here. So both by using both the type, you can import the data. So I have imported the data directly from there. So here you can see I have copied that and just paste it here. The data is copied. So importing the data, there are two methods. One, you can directly import. Another one, you can copy the link and paste it in your code panel. So you can imported the data. So let me delete it because I have already imported the data. So from first line, sharing is off. Is it visible?
Yes.
No, madam, not visible.
Sir, is it visible?
It's visible, visual.
It
Yes,
is
sir.
visible.
Actually, some break has happened. So from first line, variable images. So we are making an image collection for different time period of images. So for 2017 flood, 2018 flood, and now we are going to make 2019 and 20 flood. So get weekly Sentinel composite. This is the function. For that function, what we are going to use that from July 2015 to 2017. That is our first image. So it will consider as a 0 in the our image collection. This is 0, 1, 2, 3, 4, and 5. So 2018, this is for 2019, 2020, and for current flood, we are going to use 2021, and it is let it okay. Then okay, so this is 2017, 18, 19, 20, and for current flood we have given the 21. So now we are going to start the function. So what we are going to do? Function get weekly sentinel composite. As we name the function name get weekly sentinel composite, we are using this function, and with date, this date, and the function started from here. So variable region. So we are going to define our area of interest or region of interest, for which area we are going to use the flood monitoring. So region EE dot feature collection. So this is the feature collection, and which is imported from Rishi Patel sir. India state boundary dot filter metadata. This is from the table. So in this in the metadata, then state name is under the name one column. So this is the filter out of the Bihar state. Then variable date EE dot date, which is defined here. That date function, this date function is called here. And then variable polarization. As I said, the vertical polarization, vertically sent and vertically received polarization is better for monitoring the flooded area, because water has the smooth texture. So we use the VV polarization. And variable sentinel1, here we imported the data EE.image collection, Copernicus sentinel1 graded data. Then dot filter date. So date, whatever date we have decided in get weekly composite function, that is called from the function date. Then date dot advance 2 weeks. So we are making the 2 weeks composite. So from this date, we get the 2 weeks of composite. So from July 25th or August 1st or August 1st in 2019. So let it make the 7. From July, we are just going to check the flooded period. So it is depending upon you. If you know the flooded time period, you can make it upon that. So for 2021, we let it be for June 25, because we are going to make the 4 or 5 week composite. So within the 4 or 5 week composite, we are going to monitor the flood affected area, which is the highly flooded area during that period. So dot filter, EE dot filter list contains. So what the list in the previous classes, you know the list or dictionary. So list contains transmitter receiver polarization. So whatever polarization we have selected here, this polarization called here, because the function name is polarization. So the transmitter receiver polarization is defined as polarization, which is VV. Then dot filter, EE dot filter EQ instrument mode. There are different type of modes in Sentinel-1 data. So we are going to use the interferometric wide range, because it is freely available and the swath is bigger than other data. So it covers the large area, interferometric wide range mode. So we are going to use the IW mode. Then dot select polarization. So polarization is VV. So VV polarization is selected here, like as we select the NDVI band or band 4, band 3, band 8 in optical data, like that we are selecting the polarization. The polarization is denoted as the VV band. Annotation, the shared content. During annotation, you cannot control the shared content until you stop. Okay. So this is what she requested me, this kind of thing. I got a request from someone for annotation. So look, like this, dot select polarization, dot mean. So what we are going to do, we are going to do the mean of 5 weeks. So in between the 5-week data, in the 5-week data, we are going to select the mean of the data. Audio also, PPT not clear. There are some chat messages in chat box. Let me see.
Actually, it depends upon the networking issue of the receiver end. Anyway, we will be providing the recording. So you please continue. It is visible. Your audio is very clear and your screen is also clear.
Okay, sir. Someone said that audio is not clear, voice is not clear.
That may be an issue at their end.
Yeah, sir. Then we are going to call the Sentinel-1. Then Sentinel-1, that is variable is already defined to Sentinel-1 equal dot clip region. So region, our region of interest, which is decided, that is clipped because we are going to clip the area. So that is region. Then return Sentinel-1 dot visualization parameter we have given here to visualize our map. So minus 30 is minimum and maximum -5. Then palette, aqua, blue, red, and brown, and opacity. As you see the background images, background Google Earth Engine map in the image, like you can easily find out the area name, Muzaffarnagar, Darbhanga, Pursa, Samastipur. So that's why we have given the opacity 0.55%. If we give it 1, then it will be opacity, it will be 100%. So we cannot visualize the map. And if we give it 0, then background image will not be clear. So that's why we have given the opacity 0.55%. So this is for the flood identification. And then we are going to do for mapping that split panel, this panel in before image and after image. Let it run. Like you are seeing, here you can make the no flood and here current flood. So this is the left panel and this is the right panel. And one thing I have not mentioned, that for no flood period, you can take any year. For non-flooded period, like I have taken for March 2018. So this is generally, this is not the monsoon season. So for, in the non-monsoon season, you can take any time period for not flooded period to monitor the flood affected region. So in left map, you can see the non-flooded area. See, this is the non-flooded area and this is the flooded area. So this is the difference. So we are going to do coding for making this panel now. So variable left map, UI.map. So we are making the UI, user interface part. This is user interface part. So UI.map, left map, set control visibility false. So whatever control visibility, it will be false. It is depending upon us. So whatever control we want to give. So variable left selector, add layer selector, left map 2. So whatever map we want to display here, like when I have clicked on run button, the 2019 flood has come and here 2020 flood has come, because I have given here 2 and in right map I have given 3. But when I give here, this is for 0, in image collection, this is 0 band, 1, 2, 3, and 4, and 5. So I have given 2, so 0, 1, and 2. That's why here 2019 flood come, and in this panel 2020 flood come. So when I give here 5 number, because 0, 1, 2, 3, 4, and 5. So the no flooded period come on the left panel. So let it do for 5, and here for 2021 is on the number of 4. Run. See, here no flood, and here current flood has come. So when we swipe during the no flood period, and flooded period data has displayed in the panel. So this code is for making the data visibility on your panel. So which data you are going to select. For right map, I have again done the same thing. UI.map, set control visibility false, variable right selector, add layer selector, right map, this is false. So I have given 4, and then top right. So the panel, this panel is coming on the top right. And for left panel, I have given top left. So this panel is coming on the top left.
So these functionalities, preparation
These
of panel.
functionalities are for this panel, making this panel, and the which map is selected in this panel.
Yes, yeah, Pragati, I am seeing the participants who have seen the earlier sessions. We have explained how to look for any method in the docs tab. So this UI is an image. Sorry, it is a Earth Engine,
user interface.
It is a user interface. It is an Earth Engine class, and under UI there are many methods which are listed. They can search for it like UI.label, UI.map. They can search under the docs tab. And there, all the documentation is there. How to make the panel, how to make a split panel, how to visualize. So they may have a look, and also they may go through examples which are given under the scripts. So yes, please go ahead.
Then we are going to create this map panel. So function add layer selector, map to change. On change, when we change here, so this function is for map to change default values. So whatever default values we are giving here, that will come, and position. So this is the function's name, map to change default value and position. So we are going to elaborate it here. Variable label, UI.label, choose Sentinel-1 imagery. So this is the like this, choose Sentinel-1 image. So this is defined here. UI.label, what is the label coming in this panel? So choose Sentinel-1 image, then function update map. When we click on any map, that map will update. So update map, selection, map to change. Map to change function I have declared here. Map to change, that is called here, dot layer, set value 0. So value will be 0 always. UI.map layer, image selection. So on image, whatever image I am going to select here, so I have given the value 0. So whatever I have given in top right map, left map, that is coming. But when I select, then this map will reset. So that's why the dot set is 0. So updating map, for updating map, it is given for 0. Then variable select, UI dot select items. Whatever item is selected. Object dot keys. Dot keys is a function. So images. In this images, Sentinel-1 images. So what images is coming on change function? This is the function update map. So update map is a function that is called here to selecting the map in this panel. For selecting the map in this panel, UI panel, this function is called from this function update map. So update map, when we select any map from the UI panel, that will be updated. This the previous map will be removed, and the selected map will be displayed. So update map, this will update the map automatically. In variable control panel, UI.panel, the widgets, label, select. So whatever label I have decided, like here, label, variable label, choose Sentinel-1 image. This label is decided here, that will call here. So what is declared in the UI panel, that will display the label select. So I have selected the select function is here. So when I select any other image, that will selected, and the change update while updating, and style position, the position. So position I have defined here, the position function in this function. So there are three functions: map to change, default value, and position. So whatever position is coming, that is defined here. Map to change dot add control panel. So in this control panel, map to change function has called to update any map, whatever map is selected. So this function is about to selecting the map and displaying the choosing according to your choice which year you want to select. Then the split panel. Now we are going to make this split panel, left panel and right panel, and this swipe button for displaying this panel. So variable split panel, UI dot split panel, first panel, left map. Left map I have defined in line number 32, from 30 to 32, and right map 35 to 37. So this is called in this split panel. So first panel is left map and second panel is right map. In first panel, the left map will come, and in second panel, the right map will come, and wipe. This is the wipe tool. So wipe tool is true. When I make it false, then this wipe tool will not come. So that's why I have given it true. Style stretch. So this will stretch both. So we are stretching the both imagery. Then UI.root widgets.reset split panel. So when I select any panel, then this split panel will be reset. Variable linker. This is for linking both the map, and as we zoom out or zoom in one map in one panel, the another panel will be zoom in or zoom out. So this is for linking both the map, like as we did in ARC or ADAS, linking two maps. So UI.map linker, left map and right map. Then left map dot set center. This is for centering the object. Like I am going to center the Bihar region. So this is for set center. This 85.5465. This is latitude longitude for setting the center of the image. So this code is for monitoring the flood in Bihar. So now we are going to display no flood and current flood. So in left panel, as we have given the March period, there is not flooded data. Only permanent water body we can visualize. But in right panel, we can easily see this Darbhanga region, and here and this near the Lakhisara. This is the flooded period, as also in the Patna. When we zoom in, then we can easily see this region of Patna is filled with the water. So for monitoring the flood, water inundated pixel, we are using the microwave data, and this code is for monitoring the flood. So this is one type of code. This is shared in the repository. The repository will share with you in user Singh22 Pragati and WA training. And here is the flood, Bihar flood, Assam flood, flood affected land use land cover, and flood in Gujarat. So this code is for visualizing the flood affected area before and after, to visualize the whatever area is affected with the flood. Now we are going to discuss the flood affected land use.
Pragati, before going further, I want to add something. So if because the feature collection is a public data set where any state can be selected, and if anyone knows about the known flood events of any state, they have to just change few things, like they have to change the state, they have to change the dates and some other variables, so they can use this script for any region of interest. Is it so?
Yes, sir.
So okay. So and if they know any flood event, the start date, then they can advance for the flood period for 1 or 2 weeks. They can visualize and compare with the no flood situation for
Yes,
known
sir.
areas.
Like here, I have selected for 5 weeks. They can only select for 1 week.
Okay.
So it is depending upon you if you know the flood situation. And from here, you can just change the state name. Like here is Bihar. So change it Assam. As it is set center is in Bihar, so Bihar is displaying.
I think you
Because
have
we
to
have
change
done the
a few
state
other.
center. Yes, sir.
Okay,
Yeah.
we may go ahead with the next script.
Yeah, this is for Assam. So it is on you for which state you are going to select. So you can just go here and change the state name. Only you have to just see that the first letter will be caps, and another after that the all letter will be in small. So it can be changed for any state. Select for other. So flood affected land use, land cover. So let me show you firstly.
Yes, Pragati, please explain the purpose again, what this
Yeah.
script does.
Yes, sir. That's why I run the code. This when we are monitoring the flood, we have to also monitor the whatever area, whatever population, which population area or which land use is affected with the flood, because government uh, give compensation and send immediate response to that area. So as the settlement is affected more, then government needs immediate response. Is if the agriculture area, so government again need to give the compensation to the farmers because they lost their agricultural land or other in other area. So we have to not only monitor the flooded area, we can also monitor the flood affected land use to for giving immediate response to the flooded area. So for this, this code is for monitoring the flood affected land use like agriculture, settlement and other. In this panel, settlement area is not displaying as a bar chart because the settlement affected area is very low, and by stretching the panel, because the minimum value is 0 to 10,000 hectare. So it is around 20 or 22 hectare, 25 hectare. So it cannot be displayed here. But when you click here and download this CSV file for flooded area, open it, and you can see whatever the flood affected settlement is in that region. So this is agricultural land use affected with the flood, settlement and other than this. So you can monitor again whatever area you want. Either if you want to monitor the flood affected forest cover also, you can again monitor. So what we are going to do, we are going to import the land use land cover map, which is freely available in Google Earth Engine. So the Copernicus global land cover layer. We are going to import this layer because it is freely available for whole world and the spatial resolution is 100 meter. So this is 100 meter resolution Copernicus data, 100 meter resolution Copernicus data for whole world, which has bands So discrete classification. This band denotes the land cover classification. And the minimum value is 0 and maximum is 200. So there are around 200 classes in this global land cover map. But they generalize it with the value, like they created it for 10 or 20 classes, because they give 10 value for one class, 20 value, 30 value, like this type of value. And they already defined the visualization parameter. These are the classes, these are the bands in land cover map. And here, the visualization parameter is already defined. So we are not giving any visualization parameter for any classes. Like black color is for unknown or not enough satellite data available. Yellow color is for shrub. This mud yellow color and this yellow color is herbaceous vegetation. And this color is cultivated managed vegetation agriculture. So the purple color is showing the vegetation cover area and red is for urban and built up. So we are going to select these two classes. So that's why I'm just displaying why I am not giving any visualization parameter, because when you see my code, I have not given any visualization parameter for land cover map. So this color is already defined in this map. So you can directly import it here, or you can just copy it from here, or you can just select this like this and copy it. So there are two methods, as I said in previous code, to importing the data. Let me show you the land cover map. This is the land cover map for Bihar region. So first line, so variable ROI, this is Bihar. You can change it as for your area of interest. Then center object is 7. This 7 is given for the zoom level. When I make it 9 and run it, the zoom level will be increased. See, the more zoom data. So this 7 is for zooming the data, and center object to centering our area, to open our area of interest directly for center object. Then variable land cover, ee.image, Copernicus land cover, as I had copied from there, 100 meter PROBA global land cover 2019. Now see, this land cover data is available from 2015 to 2019. So I have selected 2019 imagery because it is more recent. You can select here 2016 if you want to check the 2016 flood. So it is for that. Then dot select. As I said, discrete classification has land cover classification. This band has land cover classification. So I have selected the discrete classification band. Then dot clip ROI. As our region of interest is Bihar, so it is clipped here. Then map dot add layer land cover. I have added in on line number 6. So the first map, when you added in the map dot add layer, that will display it in the lowest part, like here. Land cover map is displayed in the lowest part. So if you want to change the sequence, you can add it in the last. If you add it in the last, it will come on the top. So adding the layer, it is depending upon you, which layer you want to display on the top side or on bottom side. It depends upon you. So from line number 9, variable collection, EE image collection, Sentinel-1 image. As I said, I have selected the image link. I have imported the data. Dot filter metadata, orbit properties, pass equal descending. I have selected the descending pass. There are two passes in satellite microwave satellite imagery, ascending and descending. As I said, there is no limitation for microwave satellite for capturing the data during the day or night or any weather situation. So ascending and descending, two passes are available. Ascending pass during the day, which is from north to south in Sentinel-1 imagery, and during the night from south to north is descending pass. So I have selected the night period data because during the night the water pixels can be easily identified. It is more clear. So I have selected the descending pass data. And dot filter, EE dot filter list contains transmitter receive polarization. As I defined in previous code, polarization as VV, then I have called the polarization here. And now I have directly defined the VV polarization here, not defined any other place the polarization. So VV polarization is directly called here. Then dot select VV. Then variable S2 image. I have selected the Sentinel-2 imagery to display you. So before flood and after flood imagery is also displayed here, like post flood Sentinel-2. Let me show you.
So Sentinel-2 is a optical data.
Optical data.
So
in Sentinel-2, you cannot see anything. The whole region is cloudy. So making the difference between optical and microwave data, I have visualized both the data. See, in microwave channel, you can see the water pixels. See, in the in optical region, you cannot see the flood affected area as in the microwave region. See, in the microwave region, you can easily see the flood affected region like this area, this area. You cannot see in the optical region because the whole region is cloudy. Monitoring the flood, the microwave data is very important.
Pragati, hello.
Yes, sir.
Pragati, little bit zoom on the image, na, in Sentinel image, and then we can see the features.
Yeah.
Yeah, so there will be difference between the Sentinel and this image.
This is the Patna.
Yeah.
See, in optical region, the whole region is cloudy. And in microwave, we can easily see the water inundated pixels. So you can easily identify the water inundated pixels in the microwave region. Then we are going to do the different method than previous one. In previous one, we took the mean to visualize the data, but here we are going to analyze the flood affected land use. So we have to calculate the flood affected area. We are not only visualizing the water inundated pixel. We are going to analyze the flood affected area or water affected region. So what we are going to do, variable smoothing radius. So we are going to smooth the data because there are some scattering. So we have to smooth the data in microwave region. There are many type of speckles. So we have to smooth the data. So smoothing radius is 100. So at any point, the 100-meter radius will be created for smoothing the data. Then different upper threshold. This threshold is decided for making the difference from before flood imagery and after flood imagery, because we have some permanent water body in any region. So we are going to calculate the water inundated pixels because microwave provide us facility to monitor the water body area or water inundated pixels. So there are some permanent water body also in Earth surface. So we have to remove that permanent water body to monitor the whatever area is inundated with the water after the flood period, because water inundated pixels which is already available on the Earth surface as a permanent water body that cannot be calculated as a flooded area. So we have to remove that area from our flood affected region. So this threshold minus 3.5, as I said, the value of Sentinel-1 data is minimum minus 50 to maximum 0. So the difference between two images is minus 3.5. So before imagery, I have selected the collections, which is defined here, the collection, Copernicus Sentinel-1. This defined as a collection. This is in variable collection. So I have called this collection here. So before, yeah. Is anyone have any question? Someone is speaking, I think. Okay, no question. Then. Variable
threshold value explain kar do, threshold value.
Okay, threshold value is minus 3.5. So when we make the difference between before imagery and after imagery, so the threshold is 3.5. The difference between two imagery, the value of two imagery, like let me click at any pixel. Okay, this is the value, minus 21 for that water pixel and minus 17. So the difference between these two values, pre-flood and post-flood. As the flood affected area is higher, the value is increases. So the difference between these two pixels should be greater than minus 3.5. So this threshold is given here. So when we subtract one image from another image, from after image to before image, because we have to monitor the flood affected land use, not the permanent water body will not consider as a flood affected area. So we have to remove the permanent water body from flood affected region, because we are in the satellite imagery, in before imagery and after imagery, we monitor the water inundated pixel, not actually the flood affected area. So when we monitor the water inundated pixel, so we have to remove the permanent water body from flood affected region. So that's why we have to decide some threshold. That threshold should be depending upon us or our interest or our knowledge. So this threshold is defined as a minus 3.5, because during the flood period in India, there is also paddy cultivation. So that fields are also inundated with the water. So we cannot indicate that paddy field as a flood affected area if there is that is not affected with the flood, because if the paddy is flooded, then this value is already increased. So that's why this threshold is decided minus 3.5 to remove the permanent water body and paddy cultivation from the flood affected map. So is it clear? Shall I move?
Yes, go ahead. Someone asked how can we calculate threshold values? I think that you have said we have to
Yes,
look at the values before pre-flood and after the flood.
Okay, I'm going to explain that when we are going to click at any water body in microwave data, like this black pixels, ignores all the layers. Taking time. So just click at any pixel. It is water inundated pixel. It displayed totally black in imagery. See, in pre-flood, the value is minus 14, minus 17. But in post-flood, the value is minus 14. So when we are going to make the difference between two, the value should be greater than minus 3.5. This is the post-flood imagery. And when we are going to click on the pre-flood imagery, let me show you. So see, sorry, I have selected the Sentinel. See, this is the permanent feature because during the March period, it has also already the water. So we have to remove this from our flood affected area. So let me display flood affected region.
Maybe you can take one point in
Yes,
within
sir.
the
That is
river.
flood
In the river.
affected.
In
So
the
let
river,
me
it's
go there. Yes, sir. So
in
this
main Ganga. If you can select any point,
this area.
this is flooded area. What I am saying is, if you select within a permanent water body like a river or any lake, I think
Yes,
the
sir.
difference in the values won't be much. That
Yes, sir. Sir, see, this is the agricultural land. So it has already water body. But let's come to the yes, there are some sediments. So these sediments is also affected with the water after flood. So this image, when we click, because there are some permanent water body, the channel is shallower during before in the other season, but it becomes larger in the raining season. So that water body is also increased. So when we click like here near the river, so -7 is pre-flood imagery and -21. So the value is increased as we go. So from 0, it has not flooded area. When we move beyond -12, so the more water inundated pixels we can easily identify. So the value after -12, less than -12, like -39, -14, -15, -16, -17, that is the water pixels in Sentinel-1 imagery. So this value is for used for thresholding. So for water inundated pixels, as we are using the before flood imagery and after flood imagery, so that threshold value is decided. So before flood, I have used the -15 because there are some shallow water body or some cropped area that has some water. So it also captured as a water body. So I to not for removing that error, I move from -15. So I have taken less than -15. So the value which is less than -15, that will consider as a permanent water body in before flood imagery. And this is for displaying the Sentinel-1 data, Sentinel-2 optical data. So Sentinel-2, the same date has taken here. And in after imagery, again, the same value is taken. You can increase it as if you want, because there are some permanent in field, paddy field or any other field that is rainy season. So to remove the soil moisture or some other feature, you can increase this value. So it depends upon you. I have taken it -18 in my other code. So you can take -18 or -15. So it depends upon you, whatever value you are going to select. And when we remove before imagery from after imagery, the value should be greater than -3.5. So that's why this threshold value is given. So after imagery, then variable difference smooth. So after dot multiply aft. So in after imagery, we have just mosaic and clip, and in aft function, a variable, we have decided the threshold value. So here we have created 0 and 1 image, value image. When we give, when we classify, here we have classified the imagery. So after imagery dot less than -15. So it will create a single band image and with two values, 0 and 1. So it has only two values, 0 value for non-water inundated pixel and 1 value for water inundated pixel. So whatever pixels which has value less than -15, that will become 1 and rest the pixels become 0. And in before imagery, it is also for the before imagery. So what we did after this after image dot multiply after. So what the value in this pixel. So when we multiply 0 and 1 with any value, that will become the value in the imagery that has some values. When we multiply with 0, that will become 0, and when it has some value like minus 21, -7, that will become -21, and other than that value, the value will become 0. So water inundated, for giving the value to water inundated pixels, we multiplied with 0 and 1 to remove the non-water inundated pixel from the imagery. Is it clear? Or can I clear it again? Okay. So for making a water pixel and other in microwave region. So non-flooded area and flooded area. So we have removed the non-flooded area, making a mask. So here I have make a one mask for flooded period and non-flooded period. So the mask becomes with 0 and 1 value. So 0 value, remove the area which is not flooded, and 1 is the flooded area with value of the pixels. So we can when we subtract one imagery with other imagery, so we can easily have the values, because I have decided here threshold value -3.5, because when I subtract after imagery with before imagery, see one example. When I remove with 0 and 1 value with 0 and 1 value, like here after and before have only two values, 0 and 1, 0 and 1. So there is no need for this different of a threshold. So this to use this threshold value, I have used made a mask for 0 and 1 and then multiply it with our original imagery, original satellite imagery, to remove the non-water pixel from our satellite imagery and then use it for monitoring the flood affected region. So after dot multiply, I have multiplied our original imagery with mask imagery, 0 and 1 value, then dot focal median. So I have decided the focal median radius is 100 meter. That will be in circular form in meters. So 100 meter in circular format, it will create like this. See, here are some circular format. So it will take the 100 meter pixel and create a single smooth imagery. So making the smooth, because you can see some noisy part when you see this is the microwave data. So it is not much clear as in optical data. In optical data, you can easily identify any feature, but in microwave data, it cannot be easily identified. So to identify any data, we have to smooth the data. So I have smoothen it. So the smoothing function is called here, and then subtract before imagery, multiply mask. So here the 0 and 1 value is again multiplied with the original imagery to remove the non-water area, and the water area has the value. The water pixels which is subtracted from the after imagery, it has values as in the satellite imagery, and other than that which is not affected with the flood, that will remove as a 0 value. Then dot focal median, smoothing radius, circle and meters. So we have subtracted after imagery from before imagery to remove the permanent water body. Then now the permanent water body has been removed, but in the other season, like in March or April, in other season, the area is not, the agricultural land is not filled with the water because there are some wheat cultivation or other cultivation that is not rainy season. So the crop is in the field, it is not inundated with the water. But during the flood period or during the rainy season, there are water inundated pixel because there is a paddy cultivation in the field. So we have to remove it. So we have water inundated pixel, which is more than flooded area because of paddy cultivation. So we have to remove. So removing that pixels, we have to decide the threshold. That's why we have decided the threshold value minus 3.5. So different smooth imagery less than minus 3.5. So minus 3.5, that upper threshold is taken here. So whatever pixel that value has come less than minus 3.5, because when one imagery has minus 21 and another has minus 7. So when subtracted it make us value like 14. So it is less than minus 14. So the value is more. The value is less than minus 3.5. So that pixel will be considered as a water inundated pixel or flooded pixel. So here we have just classified the flood affected area. Now we are going to calculate the flood affected area. So till here, any confusion?
I think it will take some time to sink in. Anyway, we are giving the script because it is a bit lengthy code, and
Yes.
and also it is many functionalities are new. They will take some time. Anyway, you
Yes.
please go ahead. From this point onwards, you will be explaining the area, flooded area. So
Yes.
yeah.
Now we are calculating the flood affected area. Like here it is displaying flood affected area. So it is 33,403.46 hectares. So we are just going to calculate this area, whatever area is calculated as a flood affected area. So variable flooded area, so different threshold, it is defined here, dot multiply image dot pixel area. So image pixel area, whatever pixel area is in that image, that will take here, dot divide 100 by 100. You can take it 10,000 to calculate in hectare. So I have taken 100 by 100. You can also make it 10,000 directly. Sorry, 10,000 directly. So it is upon you, whatever you want to do. So I have taken it 100 by 100. Then variable stats. Now we are going to calculate the stats. So flooded area dot reduce region. So our area of interest, that is the function. Then reducer, that reducer is a function in the GE. So EE reducer dot sum. We are making the sum of all water inundated pixel or all flooded area. So we make the sum. Geometry. So for which geometry? For our region of interest. Then I have taken the scale 500. As I said, the scale of Sentinel-1 imagery is 10 meter. But I have taken here scale is 500. Why? Because GE has some limit. So it cannot calculate for that large area a value. When I make it 10, when I make it 10 and compute it, it will make a computation time error because the limit is end. That's why I made it 500. So let me display you. It will come. Let it come. It will take some time. So the error will come, and you will not be able to calculate. But when you are calculating the flood affected area for a very small region, like for any district or any town, so you can make it for 10 meter. So it will give you more accurate result than the 500, because here we are resampling the image as a 500 meter pixels. So max pixels, how many pixels it will calculate? It is 10 e raised 19. So at 10 e raised 19, when I will not give it, so the max pixel, it will not calculate the area. The error will come. So that's why the max pixels is given here. You can also give best fit true. Here best fit and here true to calculate the area, more area, because the limit will not exceed.
Yeah,
So
let
this
me
function
let
is
me.
for calculating the area.
Yeah, we have seen this function reduced region in the earlier sessions when we explained the basics. Then we have explained what the purpose of max pixels. If we are not giving max pixels, the default value will be given. Here, because we are operating at a state level, at the level of Bihar,
Yes.
if we take 10 meter as a scale, it will exceed the max means they will
Maximum
get after
limit.
maximum limit. So we are increasing the scale to 500 meter. As she said, if you are selecting a region of interest as a very small region by through geometry tools or any other way, then you can have a better. You can get for accuracy purpose. You can go for better scale.
सर स्केल चेंज करने से एरिया इफेक्टेड चेंज नहीं करेगा?
हाँ, वो भी चेंज होगा क्योंकि हम यहाँ पे क्या कर रहे हैं कि जो हमारा पिक्सल साइज है उसको रीसैंपल कर रहे हैं, तो जो फ्लड अफेक्टेड एरिया है वो आपका रिड्यूस हो जाएगा या इंक्रीज हो जाएगा. So,
the thing is, overall area there won't be much difference because
yes.
Only the pixel size is changing and pixel area is also changing. Therefore, there will be some change. But because we have to calculate, ultimately we want to get the result. Otherwise, it is throwing error. So this will give some idea at the level of state level. You will get some idea, some broad figure. You want a better accurate result, you have to go for a smaller region, and then maybe you can accumulate district wise or taluka wise, then you will get accurate figure.
Then from here, variable inspector, we are going to make an inspector panel like this panel, UI.panel. We are declaring this panel, UI.panel, UI.label, click to get flooded area. This click to get flooded area is defined here. Map.add, this panel is map panel, which is this panel, which is shown here, that is given by Google Earth Engine. This is map panel. So in this, when we want to add any panel in this panel, we have to add it. So map.add inspector. So inspector panel will be added here. So map on click function. So when we click on the map, I have clicked here. So map on click function is decided. So map on click function chords. This function is named as a chords one. Inspector, this inspector called here dot widgets set 0. Then we have set 0 on the 0 value. When there is no value, UI.label value loading. So when there is no value on that inspector panel, it will show us the loading. It is calculating the area here or on the background. When it the Google Earth Engine code editor is calculating the statistics in the background. So for that time period, the loading will be displayed. So that's why the set 0 is displayed here as a loading. So this is decided here, value loading, style. So we have decided some style, color gray. So this is coming as a gray color loading. When we give it black, then it will coming as a black. So see, as I said, when I give it 10, so dictionary error, computation time out. So that's why I have resampled the image for 500 meter. If you are asking me not 100 meter, I had tried 100 meter, 200 meter, 300 meter, all the things. So then when I go to the 500 meter, it gives not the error. So you can also check it.
Good morning, ma'am.
Yes.
What does actually scale does hit here?
Actually, it is on the spatial resolution, the pixels, the pixel size. The 10 meter pixel size is resampled as a 500 meter by 500 meter pixel size. So the pixel around 50 pixels by 50 pixels kernel will become 1 pixel here.
Then
I
it
will,
will give an error, na?
and I
Yeah,
will,
for larger area it is okay, but if you are going for accuracy, you make the your region of interest a small area, like for a district or taluka or any boundary or any geometry where you want to calculate the area. It is a generalized code for showing the state-wise flooded area. But if you are going to do for any district-wise or accuracy level, if you want to see it for accurate, so you give it 10 meter and reduce your region of interest, because Earth Engine has not the capacity to calculate that large area. So that's
actually,
why
I will explain. Let me see. Every user in Google Earth Engine, he has given some. It is even though the computational power is very much superior, but every user they have fixed a quota. So you cannot exceed. So they have defined for each user upon accumulating so many pixels, like 50,000 pixels, it will throw error. So if you are giving 10-meter resolution, and the number of pixels will be more, so you will not be able to process, you will not you won't be able to run the script. So that's why we are giving 500 meters instead of 10 meters, and because we are operating at state level to get broad idea of the flooded area. You are correct, the flooded area, there will be some variation, because we are some pixels which were showing as flooded at 10-meter resolution. When we are when see in a 500 by 500 meter pixel, there will be many 10 by 10 meter pixel. So if sometimes there may be many 10 by 10 meter pixels which are flooded, but when it comes to that 500 meter pixel, it may not be showing flooded because the area, overall area may not be flooded. So that way there will be some variation in the flooded area. For better accuracy, you have to go for, as she said, you have to go for a smaller region. But this script, we are only having, we just want to see at the state level how to get broad area, flooded area as per the land use. How much of agricultural land is flooded, how much of built up area is flooded. So this code is for that purpose. I think it is answered.
Got it. And what is the function of maximum 10 at the rate of 19? What is the meaning of that?
Just like see, there are default values. In the third lecture on raster data, I have explained actually this. If you are not specifying this maximum pixels, I think default value is around 10 power 6 only. So once it accumulates computation or 10 power 6, it will automatically give error. So we are specifying here, along with scale, changing the scale, we are also saying max pixels computation can be done up to 10 power 90. And there is one more parameter in this function, reduce region, best effort, I think.
yes.
Best effort. So once we are giving it, best effort can be true or false. If you want the result output, final output, you have to set the best effort to true. So even if max pixels is exceeded, it will change the scale. Like it can take it as some 700 meters, and it will give you the result. Is it so, Pragati? Am I right?
Yes, sir. Yes, sir. Yes.
Okay.
Please go through the documentation once, you will get some idea. And also basics we have covered this reduced region.
Thank you.
You may also watch it once.
Okay. So then again, yeah,
I have a question.
you are not audible.
Hello.
Please message in the chat box, because you are not audible clearly.
Okay.
Yeah, please, you may go ahead. Meanwhile.
Okay, sir. Then here what we are going to do, variable point dot geometry point. So for at any point, we are going to calculate that CORDS1 function that's loading this. For calling this function, we have decided the point dot geometry point CORDS longitude and latitude. For this longitude and latitude, we have decided that CORDS1, this CORDS1, and for latitude and longitude. So it will compute the value for this area on clicking at any point. Then variable compute value stat. This is stat function for statistics. This is stat function I have calculated the area here and displayed it on the on this panel. For displaying on this panel, I have to call it in another function, another variable. So for compute value, the stat dot get VV. So that statistics function is called for VV band for water inundated pixels. So stat dot get VV to calculate the flood affected area, print compute value. So whatever value or this value is already computed here, like see this 33403. When I close this print value, it will not display in the console. So I have printed it here. Then to display in our UI panel, compute value, this compute value dot evaluate function. Here I am going to give function results. So the function name is result. Inspector, this inspector panel, as I have decided this panel as a inspector panel. Dot vj set 0. So UI label. So after this, when the value has not come, the loading will come. But when the value has arrived in the console, whatever is displayed here. So I'm going to define that inspector.widgets set 0. So after coming the value set 0 on the 0 level like this. When I give it 1, then loading and flooded area both will come. Let me show you. Reset and run. So to refresh the loading, I have declared here 0. Click. See, loading will also come and flooded area also seen in this panel. So to remove that loading, reset and run. Then set 0 is for that. UI.label. So whatever label will come, value flooded area in hectare. So this flooded area in hectare, it is defined here, plus result, this function result dot to fixed. So after decimal, how many points will come? So it will come 2 points. So for making it here 2 points, that is decided here. So compute value, the value, this value from the result function, the 2 point after decimal, there will be 2 digit will declare and with flooded area in hectare. So we have calculated flooded area in hectare. So that this will display in this UI panel. Then print stat. So whatever stat will be there, that will print. And map.add layer before one. So now we just displayed here the imagery. So that before one imagery is pre-flooded Sentinel-2 imagery. See, this before one imagery has 3 band 843. So optical data, to display the optical data, so see, in before flood imagery, there is also cloud. So in optical imagery, we cannot identify the water pixel if there is cloud. So before imagery, after imagery, both have the cloud. So before, then before is for Sentinel-1. So whatever value is displaying -15, maximum 0. So beyond the less than -15, whatever pixel is available, as I given the threshold value for water inundated pixel is -15. So the image is displayed here. See this image. So whatever pixel is less than 15, that will display automatically black. So to making the more clear image for identification of flood water inundated pixel, I have given the -15 value. You can give it -50 also, but the identification of water inundated pixel will become lower. See, reset and run.
Make it -50.
Sir, actually the minimum value is -50 for Sentinel-1 imagery and maximum is 0.
Yeah, but
So
there you have put +50.
Yes.
In the script.
Yes, sir. I have done the classification and making the more clear imagery. So when I have given -15, so the water inundated pixel can be easily identified from that imagery. So that's why I have given the minimum value is -50. Then map. This is for map adding the Sentinel-2 imagery, Sentinel-1 imagery before flood. So post-flood imagery. Oh, I have given it for pre-flood imagery. That's why it's, yeah, see. Let me show you. Sorry, products. See, the whole pixel looking white because the minimum value is -50. So when I have given, so we have to decide some threshold. So that's why I have given here -15. So next run. Then map.add layer is difference threshold update mask. Now I have updated the mask. This is update mask does the removing the whatever pixel has the 0 value. So here you can see only the blue pixel for flooded area. So rest of that will remove from the imagery. So our classified image. So update mask function is to removing the 0 value. So update mask different threshold. So less than -3.5 or the pixel has 0 and 1 value. So 0 value is removed from the image. Only the water pixel or flooded area is displaying in our imagery. And palette blue, it has only one class. So we have given only one color and flood. So the flood is displaying here. It is just an example, not the accurate. So it needs
Hello,
some
ma'am.
Yeah.
Ma'am, can you please go to line number 37?
37. Okay.
Yes.
Yeah, here.
Yes, ma'am. As you have told, like this, we are taking a difference of pre-flood and post-flood, and if
Yeah.
that difference is more than -3.5, then we will consider that as a flooded, right?
Yeah.
But ma'am, here you have used less than. It should be greater than. Or I have that question. It has to be GT, na?
Okay. Let me run you.
Yes, ma'am.
Yeah. Sorry, there is some mistake in the code. Thank you.
Okay. Thank you. Welcome. Yeah.
Yeah. Thank you. So mistake is also done from anyone. Can be also done by anyone. Thank you. Okay. Now we are going to calculate the flood affected land use. As I said, I have used the land cover data, which is already available. This is already available in Google Earth Engine. So now what I did here, just map.add layer land cover and not given any type of visualization parameter because visualization parameter is already provided. So just only did map.add layer land cover and this curl bracket because it will already call the visualization parameter, then land cover. So the land cover layer is given on the top, so it will come on the bottom of the map. So now we are going to analyze. So use the inspector panel if you don't know the classes. So zoom in it and make the easiest form to analyzing, make the satellite imagery on the background and zoom in. So see, this is the agricultural land. You have to click here to know the classes. If you don't know the classes, you have any type of problem for getting the classes from this. So which class should be taken? Like here, which color is decided for what? So just make in the background satellite imagery like here, cultivated and managed vegetation, agriculture, land cover with temporary crops followed by harvest and bare soil period. So this is for the agricultural land. But if you don't know and you are facing any problem, so just make the satellite image on the background, select the satellite and close all the layers and click on the map and you can see the class value. So what is the value for the class? Discrete classification has value 40. So for agricultural land, they have given, this is the agricultural land. Let me show clearly. See, you can see this is the agricultural land. Zoom in. So this is the agricultural land. So you can easily identify the agricultural land or any settlement on the earth surface while seeing the building area. So when you open it, the imagery, then click. So it is 100 meter by 100 meter pixels. So this settlement is not coming in this imagery. So there are some error already available in the imagery. If you want more accurate data, you can classify imagery with Sentinel-2 data for any non-monsoon period data. So let's go to the biggest one. So this is the Muzaffarnagar and then open it. So red color is for settlement area. So click here and see class number. Discrete classification value is 50. So the 50 value is given for settlement. So we are going to use these two values for calculating the land affected with the flood. So 40 is for agriculture and 50 is for settlement. Now come here. So variable agriculture, AG is for agriculture, different thresholded value equal 1. So if the flooded different thresholded value, as I defined the flooded area as diff thresholded, so it has value equal 1. So 1 is for flooded area dot and land cover dot equal 40. So land cover data has 40. So flooded area has one value. So if the flooded area,
sorry to interrupt, ma'am, but if you are doing some means these two data are available in different spatial resolution. So
yeah,
how so ma'am कैसे ये होगा ये
See,
analysis?
Pragati, let me actually in Google Earth Engine, this is the public data set which is available, land use land cover map, which is at 100 meter resolution. It is the only, I think very few land use land cover maps and the data sets are available. I think for better purpose, Pragati and Ashutosh, they have done, they have created, they have published a paper recently. They have created a very good resolution land use land cover map. You have to prepare your own land use land cover map by giving by identify semi. You can go for semi supervised classification. You can train the you can get the training data, or then you prepare your own map having the same resolution, and then you can do this the same analysis. You can upload your map as a asset, your image as an asset, and then you can do the same. So I think we are actually we are running out of time. I would request Pragati to complete this, and then we can also go ahead with other scripts related to agricultural water management. You can,
Okay, sir.
yeah.
So here,
Hello,
the
sir.
flooded yes, sir.
Sir, can't we do reprojection, like we can reproject our flooded image to this LULC map, and then they will be at the same projection, means resolution,
sir.
and we can then carry
Sir,
out.
sir,
Yeah.
projection is different and scale, spatial resolution is different.
Okay.
So it should be clear. We can resample, not reprojection.
Okay. Okay.
Yeah, resample. But while resampling the image, if the image is already on 100 meter, so for down in the downscaling, it will not give us the better result. So
Okay.
we can use our own land use land cover map, as in previous classes you learned how to create the land use land cover map. You can create that land use land cover map and export as a asset.
Okay. Okay.
So
Thank
you
you.
can download while downloading on your laptop, desktop, you can directly export it as a asset. You can export it in your asset part and then use it, or directly you can
Okay.
classify it and then use it. You can classify it in this panel also, but the code will become too much lengthier and it will take too much time in the processing. So that's why we create that map and export it as a asset.
Okay, because I have just seen somewhere like they were then means if it is a 10-meter resolution, then they are reprojecting it by doing it to 250, and LULC map is also of 250 for Moody's data.
Not
So in that
reprojecting.
way.
Projection is different thing, and
Okay,
that
resampling. Yeah.
resampling is different. Yeah.
But that can be done.
Projection is for
Resampling can be
projecting
done.
any data according to its coordinate system or its
Okay, yes, I did a
pattern.
mistake. Means resampling, we can do that resampling now over here.
See, the original data itself is at 100-meter resolution. By resampling, you will not add anything to your analysis. You have to prepare
No, sir,
an input data set. You have to have a good input data set. You can prepare your own land use land cover map.
If you have 10-meter data, then if you and then you are resampling it on 100-meter, then it is okay. But if you have
yes,
10
I'm saying that. Yeah.
100-meter data and resampling it into 10-meter, it will not give you better result.
No, I am telling that only, that 10-meter data is resampled to 100 meters. So then we can do an analysis. But over here it is not done. So I was asking.
Yeah, then you can do. So here the flooded area, which is all the agricultural land which is affected with the flood, that is classified in the agriculture. Here we are using the two type of data. One is land cover and another is sentinel data. So we have to rename the band. So here we renamed the band as VV. So the output is renamed with the VV band in this class. For settlement, again we did the same. Here we give the 50 value because settlement has 50 value, and for other and then multiply it with 2 because we are going to add the data as a 1, 2, 3 value to make this chart. So one value is for agriculture, then multiply the 0 and 1 value with 2, so then 1 value will become 2 and another is 0. So we have created two images, one with 0 and 1 image for agriculture, another is settlement which is 0 and 2, then rename it with 2, and other classes the land cover is not an EQ. I have used here NEQ means not equal to 40. Not equal to 40 means it is not the agricultural land and not equal to 50. Not the land cover, and multiply it with 3. So not non-agricultural and non-settlement area value is given as a 3 and rename it with 3, and we have added all the data other with agriculture and settlement. So this other classes has 3 value, agriculture has 0 and 1. When we add it, so the other classes where is the 0 value, and in agriculture there is 0 and 1, so it will already become 0, 1 and 3. When we add settlement 0, 1, 2 and 3, so the value is come as a 0, 1, 2, 3. So 0 is for non-classes or other classes. Non-flooded area, 1 is for agriculture, 2 is for settlement, and 3 is for other. Then variable land use land cover update mask. We use the land use land cover update mask dot greater than 0 to remove the non-flooded area. And map dot add layer. So we have given white for 0 value, green for agricultural affected, red for settlement affected, and blue for other area. So let's open it. So green color patch is showing here, and when we remove that, see this red patches. So as the land use land cover map has not accurate data, so only small patches in between these, it is showing as a flood affected settlement, and green color flood affected agricultural land, and this blue color is other classes. So this is some kind of small channel. It is not previously, it is not filled with the water, but during the flood, it has during the monsoon season, it has come water, so it is it already showing the water body. So you can also remove the water body using this land cover data. If you have good land cover data, you can remove the permanent water body from that, or you can use the JRC data, which has already the permanent water body features. So you can remove the permanent water body features from that data.
Hello,
Then we are
ma'am.
going- yeah.
Ma'am, before applying the script from 78 line, don't we have to resample our flooded 10 meter to 100 meter before carrying out this task?
Where?
From 78, line number 78. Before that, we have to first of all resample, na?
No,
Our
you
10
can
meter to
directly
100
use
meter.
it because
There is no need of any resampling. I think we are running out of time. I would
Okay,
request
sorry, sir.
participants to ask their queries after the session, or they can always put their query in the WhatsApp group or in the classroom also.
Okay.
actually, if there is some value 0, 1 value, 0, 1 value in both the imagery, but you have to remove. So if both the imagery has the value 1, here is also 1, so then it will consider as a agricultural land. So our data for flooded area, that is in the 10 meter, so it will capture only that region from the satellite imagery. Like see here, as the land cover map is given in 100 meter, but the output has come as a 10 meter only. It will cut the area from that 100 meter. Let it come, and let me go further. You can see in the image. See here, from here we are going to create this panel. So H-axis, title, flooded area. So this flooded area is displaying vertical axis, then title of this panel, color, whatever color, green color is for agriculture, red is for settlement, and blue is for other. Background color, this blue color is decided here, this sky blue color, and legend. The right side, maximum line 3. So the legend is coming, and on the right side of the map panel, and maximum line is 3 because we have only 3 classes. Now we are going to make this chart. So variable pixel chart, UI.chart, image by class. So image, whatever value in the image, and whatever is the classes. So image by class is the function for calculating the area from the image. So ee.image pixel area dot add band LULC. So we have calculated as a LULC here. See LULC update mask, which is land use land cover affected with the flood. So LULC.clip ROI, our region of interest, dot divide in hectare for calculating in hectare, 100 by 100. Then class band is VV. We have renamed already all the classes as VV band. The region, our ROI, and again scale is 500 for removing the computation time error. And reducer is sum. I have one call. Just give me 1 minute break. Okay. Then where dot set series name. So series name. This series name has come as a green is for agriculture. So agriculture, settlement, and other. Then set option, option. As we give the name as option in previous panel for naming the for deciding the axis or other things. So option. So that option has come here. Then variable panel chart. Here we are going to create the panel. So we are going to make the chart in the panel. So in this panel, we will call the chart, or you can print the chart directly. So we are making the panel for this chart, UI.panel layout. UI.panel layout flow is vertical. So it will flow vertical. When we create it horizontal, this bar is showing vertically. So vertical style with 300 pixels. This is the size of chart. When you make it 500, it will come through here. So for position bottom right, it is coming in bottom right background color. This is the background color, and panel chart dot add pixel chart. So we are adding that pixel chart, this chart in this panel. So panel chart, adding this chart. Map dot add panel chart. So we are adding this panel in the map. So this function is for that. So see, let me show you that land cover map. See, this is the size of land cover map, and it only takes this type, this area. We have given the smoothing radius, so it took that area in that radius and cut the data, that 100 meter by 100 meter pixel according to the flood affected region. So that's why I have not resampled the data, because when I will resample, then it will take too much pixels. So for getting more accurate, because we don't have that accurate data for land use land cover in Google Earth Engine. So I have not resampled the data. So this is for flood affected land use land cover. So you can calculate the land use land cover map affected with the flood. Sir, if anyone have doubt, then I will clear it or move on another script.
Yeah, you can move on. And if you need a break or others, they want a break, you can have a short break of 2 minutes. So flood part is completed, or do we have anything more to show?
Sir, if you want, I can display JRC also, or JRC example, we can make some video because the time is moving.
Otherwise, the script of agriculture will be left. So just let's go to that script and
Yeah, then we can conclude the flood monitoring and flood mapping using Google Earth Engine here.